All right, let's look at this. Again, we're going to flip back and forth, right, looking at our formulas. It says Stephanie has invested $3,000 into the bank, and she plans to invest with its offering a 4.1% interest rate for the first 4 years. So now we're going to compound this weekly, and then we're going to compound it continuously. So let's look here first. If we're doing continuously, we can go ahead and do the PERT one right now if we wanted to, but I'm just going to save that for after we compound interest. So I'm actually going to look here then. Right? Now this is interesting because we got to go weekly. So our rate, so if we look in purple where it's in rate, right, that will be our percentage, and then N will be the number of times we are compounding. So we have to say, okay, well, we are compounding 52 weeks per year. So that number is going to be 52. So let's try to remember this A equals P, parentheses 1 plus or minus R divided by N, parentheses N times T. So hopefully we can try to remember that. Using that, we are going to get, and what I would do is when I come here, I would just rewrite that. I know you guys can keep going back and forth, but what I would do is I would just write that, right? So A equals, and if I have to flash back really quick, that's fine, right? So we got P1, and then you could pick plus or minus right now. Since this is an interest that is going to add, I'm just going to go ahead and go plus right away, right? So if this was going to subtract or decrease, then you would go minus. I'm going to go ahead and go plus right away, and then our rate is 0.041 divided by 52, so that's how many weeks are in a year, and then 52 times the time, which the number of years, which is 4. Now I probably should have done this in a little bit better color, and actually now that I did this, I might be like, okay, well, I already plugged in the numbers, so why would I put the P there? Okay, that's a good question. So I'm going to go ahead and erase that. And I'm going to go ahead and go A equals 3,000. We're getting the 3,000 right here. And now you can literally just plug that right into the calculator, right? So I'm going to go ahead and do that. What I like to do is I like to kind of do it in pieces. So I'm going to actually take the 0.041 and divide that by 52 first. And then I'm going to add 1 to that. So now you'll notice we get this 1.0000788. Okay, so it's not a very high number, but I'm going to go ahead and do that. I'm going to round that to 1.008. Right, so I hope that's all right with everybody. So now my next step is 3,000, 1.0008. So I rounded there a little bit. And that's going to be raised to the 52 times 4. So that's actually what I would do next, is I would take 52 times 4, right? So I'm going to get 52 times 4 and get 208. So now we have 3,000 times 1.0008, parentheses 208. Now the reason why I do this in pieces is because I know students sometimes look at this and then they try to type all this in calculator and then they miss like a parenthesis, right? Like for example, when it says 1 plus 0.041 divided by 52, you have to put all of that in separate parentheses. So you have to put the 0.041 divided by 52 all in its own parentheses. So you'll end up having like parentheses, and then you'll have n parentheses, right? So I know sometimes that's a little complicated for students, so I like to do it in pieces like this. Now at this point, once I get this, I just type all that in. Now sometimes I would say, okay, well, you want to take 1.0008 raised to the 208 first, but I actually can just type all this in, and I trust that you guys won't make a mistake from here. So I put 3,000, and then I put parentheses 1.12308 parentheses, and then I'm going to raise that to the 208. And you'll see, okay, good, that is 3,542.90 cents, or 0.90, right? And we're going to raise that to the nearest penny. You can see after 4 years, even though we're compounding weekly, it's not crazy amount, right? $500 isn't crazy, but it's a good investment. 4.1 interest rate is really good. If you're looking at regular bank accounts, it's not that high. So this must be some sort of good bank, right? Usually like a 2% is pretty good for banks or something like that. But now if we do this continuously, we're going to use that PERT, right? So that gold was PERT, right? So it said PERT, right? So it should look something like this. I'm going to go ahead and plug everything in, right? Our P is our 3,000. E, now our rate is 0.041. And then we're going to multiply that by our time. Well, our time was 4 years. So we're going to go ahead and do that 4 years. And now when we typed it, now I would type all this in the calculator. I wouldn't do this in pieces. You can though. Don't force yourself to do it all together. If you want to multiply the 0.041 times 4, go ahead and do that. But I'm just going to type it all in. So we got 3,000, and then E, or exponential, raised to the 0.041 times 4. And you'll see here, you get just a little bit of a number here, which is a little bit lower, right? So this should be 3,534.64. Right? So then you can kind of see what's going on there for those two. And then when we go to number 12, we're going to do a population decrease. Now, we're going to use the same population that we used before. So, I don't know, I'm going to have to, I don't want to highlight in green, so we'll highlight it in yellow or purple, so it's not the same color. But here's your growth decay of population. Now, the only difference that we're going to do here is we are going to have, say, 1 minus the rate, right? So this is going to be for decay, right? And you can kind of see that right here. I'm going to highlight this in purple as well. Ooh, that went a little darker than I wanted it to, so I'm going to erase that. So again, we're going to minus the rate. So here we have P, which is our initial population, so 40,000 multiplied 1, and then we are going, it says it has a decreasing rate of that, so we are going to subtract 0.0125, right? And I'm going to go back just to make sure, right? Good, and then I'm going to raise this to T, or raise this to the time. So how many years? Okay, so this was at a population of each year. What is the population of Deerfield in 2007? It doesn't give you a first one though. Oops, I forgot to give that. Well, let's just make this population. We'll make this population right here in year 2000. So that will make it a clean 7 years, and then you'll see how much the decrease is. So that's my mistake. I should have put a year there. But we can just type this right into the calculator. I'm actually going to do this in pieces. I know you don't have to, but I like to. I like to say 1 minus 0.0125. So I like to get that number first, which is just 0.9875. So now I have the 40,000 parentheses 0.9875 raised to the 7th power, because there's 7 years from 2000 to 2007, which gives us 36,628.54. And you can't have 0.54 people, so I'm just going to go ahead and cross that out and just say that it is this. If you want to round right there, again, to one person, I'm not going to be too picky about, especially now that we're online, so I'm not going to be too picky about that. But the one thing that I want you to notice is that it was a decreasing rate, so our number should have gone lower. So notice that it did. So I think I'm coming around to my 10 minutes again. I did okay, didn't get as far as I wanted to, but we did do this. I'm just showing you this so you can pause the video really quick. We did do this in another video, so you can look at a discussion board and see it in another video. If you have any questions about anything else, let me know, and then I can send you guys emails or discussion boards or whatever you guys need. We have our test on Friday, and don't forget about the other review that we have. It says summative review 2 for Wednesday and Thursday of this week. So we have a lot of practice for you. Please ask questions if you have them.